armed to tackle that same pathogen, that same strain of virus or bacterium or whatever, the second time around. There were two categories within the adaptive defenses, both considered part of the immune system and both provided by lymphocytes. So far we've been looking at humoral immunity, immunity provided by so-called B cells, B lymphocytes that do all of their development in the bone marrow. We saw the procedure by which B lymphocytes discover that there's an infection and begin launching an attack against it, an attack in the form of antibodies. B lymphocytes that were created in the bone marrow, they sprout antibodies on their surface as receptors, and they go colonize lymphoid tissue around the body. Now, most of them will never get a chance to fight because the particular antigen, the particular chemical that matches their antibody receptors, they're just never going to run into it. You may never actually catch that particular disease. But for the ones that do, you capture their antigen, a strange chemical from outside the body, a non-self antigen that is only explainable by it being a microorganism, some kind of pathogen. When one of those enters your body, then the B lymphocytes can use those antibodies on their surface to touch the antigen, see if it's actually something that matches them. The ones that don't match, they sit around and wait for their own antigen to show up. Each parent lymphocyte can only fight one kind of antigen. But the one that does match, when it catches an antigen, it becomes activated. Up until then, it's what we call naive, an lymphocyte that's never seen the bad guy it's supposed to fight it. But when it's seen the antigen, it becomes active. It starts to reproduce, breeding an army that we call a clone, a big population of daughter cells that all share the parent cell's ability to make antibodies against that particular chemical. That clone of B cells, some of them, most of them, are going to transform into antibody factories. They become what we call plasma cells, cells with a whole lot of internal machinery, endoplasm in particular, that they could use to assemble antibodies to fight infection. And they start manufacturing antibodies, sending them out into our body fluids. We're going to send them out into our blood, out into our lymph, out into our cerebrospinal fluid, all the body fluids of our all of our extracellular fluid gets a dose of antibodies from those plasma cells. A few of them, instead of fighting this infection, remain behind, remain as B lymphocytes. And instead of